So hey guys, welcome again to my vlog. So today we discuss the chapter 3 summary. So let's start. Networking Academy. The CCNA routing and switching introduction to network. So the chapter 3, the protocols and communication. So the introduction is more and more it is network that connects us. People communicate online from everywhere. Conversation in classroom is spilled into instant message, chat, session, and only debates continue at the school. New services are being developed daily to take advantage of the network. Within this chapter, you can learn about these models as well as the standard that make network work and how communication occurs over. So, communication fundamentals. A network can be as complex as devices connected across the internet or simple as two computers directly connected to one another with a single cable and anything in between. Networks can be vary in size, shapes, and function. However, simply having a wired or wireless physical connection between end devices, it is not enough to enable communication. For communication to occur, devices must know how to communicate. Communication begin with a message or information that must be sent from a source to a destination. The sending of this message, whether by face-to-face communication or over a network, is governed by rules called protocols. These are protocols are specific to the type of communication method occurring. In our day-to-day personal communication, the rules we use to communicate over one medium like a telephone call are not necessarily the same as the protocol for using another medium such as sending letter. So this is the rule establishment. Before communicating with one another, individuals must use established rules or agreements to govern the conversation. Protocols are necessary for effective communication. These rules or protocol must be followed in order or for the message to be successfully delivered and understood. So protocols must account for the following requirements. So this is the following requirements for protocols. The first is an identified sender and the receiver. Next is common language and grammar. Third is speed and timing of delivery, and the last is confirmation or acknowledgement requirements. So this is the protocols following requirements. So next is message encoding. What is message encoding? Encoding occurs in computer communication. Encoding between hosts must be appropriate format for the medium message sent across the network are first converted into bits by the sending host. Each byte is encoded into a pattern of sound, light waves, or electrical impulses depending on the network media or over which the bits are transmitted. The destination host receives the signals and decodes in order to interpret the message. So, message formatting and encapsulation. When a message is sent from a source destination, it must use a specific format or structure. Message format depend on the type of message and the channel that is used to deliver the message. Letter writing is one of the most common form of written human communication. For centuries, the agreed format for personal letters has not changed. Next is the message timing. Access method. What is access method? It's determine when someone is able to send a message. That is access method. Next is flow control. Flow control is in-network communication. Source and destination hosts use to flow control methods to negotiate the correct timing for successful communication. Next is response timeout. Hosts on the network also have rules that specify how long to wait for responses and what action to take it response timeout occurs. Next is a message delivery option. A one-to-one delivery option is referred to as unicast, meaning there is only a single destination for message. When a host need to send message using one-to-many delivery option, it is referred to as a multicast. Multicasting is the delivery of the same message to a group of host destination simultaneously. If all hosts on the network need to receive the message at the same time, a broadcast may be used. Broadcasting represent a one-to-all message delivery option. So, network protocols. What is network protocols? At the human level, some communication rules are formal and other are simply understood based on the custom and practice. For devices to successfully communicate, a network protocol suite must be described precise requirements and interaction. So, the next is protocol interaction. HTTP or Hypertext Transfer Protocol is an application protocol that governs the way a web server and web client interact. HTTP defines the content and formatting of the requests and responses that are exchanged between the client and the server. Next is the TCP or Transport Protocol. So, is the transport protocol that manages the individual conversation. TCP divides an HTTP message into smaller physical segments. Next is the IP. IP is responsible for taking the formatted segment from TCP, encapsulating them into the packets, assigning them the appropriate addresses, and delivering them to destination host. Last is the Ethernet. What is Ethernet? Ethernet is a network access protocol that describes two primary functions: communication over a data link and the physical transmission of data on the network. So, Internet standards or Internet Society or ISOC. So, responsible for promoting the open development and evolution of Internet use throughout the world. Next is Internet Architecture Board or IAB. So, responsible for the overall management and development of the Internet standards. Next is the Internet Engineering Task Force or IETF. Develops, update, and maintain Internet and the TCP IP technologies. This includes the process and documents for developing new protocols and updating existing protocols known as request for comments or RFC documents. Internet Research Task Force or IRTF focus on long-term research related to Internet and TCP IP protocols such as anti-spam research group, cryptoforum research group, and peer-to-peer research group. So, Internet Corporation for Assigned Names and Numbers or ICANN. Based in the United States, coordinates IP address allocation, the management of domain names, and assignments of other information use TCP or IP protocols. Internet Assigned Numbers of Authority or IANA. Responsible for overseeing and managing IP address allocation, domain name management, and protocol identifiers for ICANN. Next is the OSI reference model. The OSI model provides an extensive list of function and service that can occur at each layer. It also describes the interaction of each layer with the layers directly above and below. The TCP or IP protocols discussed in this course are structured around both the OSI and TCP or IP models. Protocols data units. As application data is passed down, the protocol is stuck on its way to be transmitted across the network media. Various protocol information is added at each level. This is known as the encapsulation process. The form that a piece data takes at any layer is called a protocol data unit or PDU. So, during the encapsulation, each succeeding layer encapsulates the PDU that is received from the layer above in according with the protocol being used. At each stage of the process, a PDU has a different name to reflect the function. So, network addresses. Network layer source and destination addresses, responsible for delivering the IP packets from the original source to the final destination, either on the same network or to a remote network. Data link layer source and destination addresses, responsible for delivering the data link frame from one network interface card or NIC to another NIC on the same network. Role of the network layer addresses. The network layer addresses or IP addresses indicates the original source and final destination. An IP address contains two parts: network portion and the host portion. So the first is network portion. What is network portion? Network portion is the leftmost part of the address that indicates which network the IP address is a member, all devices on the same network will have the same network portion of the address, host portion, the remaining part of the address that identifies a specific device on the network. The host portion is unique for each device on the network. So, role of the network layer addresses. When the sender of the packet is on the different network from the receiver, the source of destination IP addresses will represent hosts of different networks. Will be indicated by the network portion of the IP address of the destination host. First is the source IP address. The IP address of the sending device is client computer of PC1 of 192.168.1.110. Destination IP address. The IP address of the receiving device, the server, web server. So, 172.16.1.99. Role of the data link layer addresses. So, next is the role of the data link layer addresses is the source MAC address, the Ethernet MAC address of the sending device PC1. The MAC address of the Ethernet interface of a PC1 is AA-AA-AA-AA-AA-AA point. Destination MAC address. What is the destination MAC address? When the receiving device, the destination IP address is on a different network from the sending device. The sending device uses the Ethernet MAC address of the default gateway or router. So, that's all for chapter 3, and I hope you learned something from my summary. So, I'm Brian J. Asi, and don't forget to subscribe my channel. Thank you. Bye.